Hey guys, how's it going? Well, we're back at another repair of a laptop, and this time it's my beloved brick, the Lenovo Legion that I currently use as a daily driver. As far as I remember, this should be the third repaste I'm doing on this laptop because it's an absolute vacuum cleaner for dust. So we'll run a few tests and we'll see what we can do for repair. When gaming, I haven't exactly noticed any drops in frame rates due to high temperature. However, it do feel like it really needs a repaste looking at the stats. To start off with, I'll be testing just 2 games and 2 synthetic benchmarks for this repair. All the gaming benchmarks were done at 1440p. Technically it's 1600 pixels because it's a 16:10 display, but you get the point. The benchmarks were done while a second monitor was connected over HDMI as well, to more or less replicate the usual setup I use. Here's our baseline figures before the repair. We're running Apex on low graphics at 132 FPS with a CPU sitting at around 102, which is incredibly hot. H-series Ryzen CPUs of this generation topped out at 105 degrees Celsius, so we are very close to that hard throttle limit. This is shown by the clock speed as well at around 3.7 GHz, where the all-core boost clock should be closer to 4 GHz. Power levels sit at around 40-ish watts, well under the limit of 45 watts when the GPU is running hard. Moving on to the GPU, 83 degrees Celsius is very hot for something of a mobile GPU as well, just 2 degrees off the hard throttle limit. Regardless, it was pulling 129 watts at 1815 MHz. I didn't want to run the graphics on high because the benchmarks and tests were meant to be done at the settings I usually play at. And it doesn't really matter because we're measuring the difference. Also, this happened. Well, there's a goof guy. NFS Heat, on the other hand, at high settings runs at 62 FPS. This game gets the CPU again at 102 degrees Celsius, very close again to where it tops out. This time it draws just 31 watts at 3.6 GHz. Now I am aware of a CPU bug on this game that pins the usage at 90%, and I have fixed it with a script, and it helped gain a few FPS, but not a lot. The GPU is at 86 degrees Celsius, just above hot throttling, so clearly we are being limited by the GPU temperature. This is also why the power draw is only at 129, just below, well below 140 watts, and that's not even reaching the 140 watt limit set by the laptop. The clock is also heavily choked as a result, sitting at 1590 MHz. Now here's the Cinebench R23 scores and the R24 scores. On the R23 multi-core, you can really see how the CPU instantly gets shot in the foot with the temperature as the test starts. R23 is more or less one of the most useful tests to diagnose temperature problems relative to other CPU benchmarks, because it cranks out every last drop of juice out of it. One thing to note is off screen I have a clock with the frequencies, and we're sitting on 4 GHz on the single core test, and 3.7 and 3.4 GHz on all cores of the multi-core test. R24 has more or less a similar story, with 4 GHz single core and 3.4 GHz on multi-core. For some reason, R24 ran hotter than R23, even if it consumed more or less the same power. To test out the GPU, I did use the Cinebench R23 graphics benchmark as well, but for some reason over multiple passes, it would give me results that I could simply not replicate again and again. At some point the scores would be in the 8000 range, then the 7000 range, and then the 9000 range. Because of this, I scrapped the data for the GPU test. Now, taking this apart is like second nature at this point, and a few more tries and I could probably do this blindfolded. 10 screws holding the back plate. Then afterwards I take out the NVMe heatsinks, 3 screws each, disconnect the fans and unscrew the 4 screws holding them at the top and the bottom. Then 6 screws clamping the actual heatsink in reverse order. The heatsink screws are labeled 1 through 6, so it should be easy work. Now here's the heatsink. See this black electrical insulation? I'll be taking that off because I've realized that the die area of the CPU is so closely matched in size to the contact area in the middle of the insulation. Some thermal paste gets stuck under the insulation and between the copper and makes the area around the contact patch taller than usual, affecting mounting pressure. So I'll be taking this insulation off, which should be okay because there's enough clearance for the surface mounted components around the CPU. A quick cleanup of the old thermal paste around the CPU and the GPU. Clean the heatsink and the fins and the fans, and off to reassembly. Anyways, the laptop successfully restarts and here are the results. On Apex we gained a whole lot of FPS and now we sometimes even hit the FPS limit of the screen, which is 165. We only dropped 4 degrees Celsius on the CPU, but it's allowed to draw the maximum power of 45 watts. CPU clock was more or less identical-ish, but the GPU becomes a whole other story. 76 degrees Celsius, 7 degrees Celsius lower than before the repaste, and strangely, it somehow draws less power and clocks slower. NFS heat gained 3 more frames up to 65 FPS, but look at that CPU temperature. We managed to drop 12 degrees Celsius on this stretch of the road and for the same power draw and CPU clock. The GPU also draws 139 to 140 watts and clocks up to 1650 megahertz. And this results in a big improvement in performance, and it also shows an improvement of up to 7 degrees Celsius of temperature. Here's your Cinebench stats. The R23 single core CPU score and frequency happens to be more or less the same, but the temperature reduced by 10 degrees Celsius. Multicore sadly enough rocketed to the boiling point of water, but now the CPU was drawing 72 watts of power instead of 50 and clocked at 3.6 GHz, giving us a better score. R24 showed a much narrower improvement on single core, but the multi-core performance reflected the very same improvements on R23 as well. So what can we conclude with this? We did manage to drop the temperatures on the system simply by cleaning it and repasting it, but I'm not too happy with the multi-core Cinebench temperatures. To be fair, it was drawing like 72 watts into that tiny CPU die, so it's okay, I just tell myself. These are high maintenance machines and you could probably save your laptop from the lag festivities with something as simple as cleaning its intestines. So before you splurge your money on a repair shop, you might as well self-diagnose what's going on with your computer. So with that, signing out, Yasbroza.